According to the National Electrical Code Section 314.27c, support of enclosures, electrical junction boxes shall be securely fastened in place in a manner that will not impair the electrical or mechanical integrity of the box or its contents or create a hazard to persons. Surface-mounted junction boxes shall be securely supported in accordance with their listing. Concealed junction boxes shall be supported as required by 314.23. Furthermore, Section 314.23 addresses the support of surface raceways, stating that surface raceways shall be supported at least every 6 feet and within 12 inches of each outlet box, device box, junction box, and termination. Therefore, according to NEC 314.27c and 314.23a, each 1900 box must be independently supported, either by hanger wires or other approved means directly supporting the box, or by fastening the box to a surface raceway that is supported in accordance with 314.23a. When supporting 1900 boxes with hanger wires above an acoustic ceiling, this method is permissible if the hanger wires provide adequate support for the boxes and their contents. The hanger wires must be securely attached to a solid structure such as a concrete slab or structural steel framing. The boxes must be suspended from the hanger wires in a manner that prevents them from swaying or moving excessively. The acoustic ceiling must be able to support the weight of the boxes and hanger wires without sagging or damaging the ceiling tiles. To elaborate further, several factors must be considered when supporting electrical boxes, particularly junction boxes used for lighting whips, above an acoustic ceiling. The National Electrical Code, or NEC, provides specific guidelines to ensure electrical safety and proper installation. Firstly, let's define what a 1900 box is. It is a common type of electrical box, typically a metallic or non-metallic enclosure, used to house electrical connections such as splices or terminations. They are frequently used as junction boxes in lighting circuits, providing a safe and organized way to connect wiring. When these boxes are located above an acoustic ceiling, it introduces unique challenges regarding support and accessibility. The primary concern is ensuring that the boxes are securely supported independently of the ceiling grid. The NEC mandates that electrical boxes must be fastened in a manner that does not compromise the electrical or mechanical integrity of the box or create a hazard to individuals. Relying solely on the acoustic ceiling grid for support is generally not acceptable, as these grids are not designed to bear the weight of electrical components. According to NEC 314.27c, concealed junction boxes must be supported as required by 314.23. This section details acceptable methods for supporting boxes. One permissible method involves using hanger wires to directly support the boxes. These wires must be securely attached to a substantial structural element of the building, such as the concrete slab above or the structural steel framing. The wires should be of appropriate gauge and strength to handle the weight of the box, the wiring within, and any connected fixtures or equipment. It is crucial to ensure that the hanger wires are properly fastened to the box itself. This can be achieved using various methods, such as specialized clips, brackets, or straps designed for this purpose. The connection must be robust enough to prevent the box from swaying, moving excessively, or potentially detaching from the support system. Another acceptable method, as mentioned in the NEC 314.23a, is to fasten the box to a surface raceway. However, the raceway itself must be independently supported in accordance with the NEC. This means that the raceway must be secured to the building structure at intervals specified by the code, typically every 6 feet and within 12 inches of any box or termination point. If using a raceway, it is essential to ensure that the raceway is adequately sized and rated for the number and size of conductors it contains. The raceway must also provide proper mechanical protection for the wiring. In addition to the structural support, accessibility is another critical factor to consider. The NEC requires that junction boxes be accessible after installation. This means that the boxes must be located in a manner that allows for inspection, maintenance, and repairs without requiring significant disassembly of the building structure or finishes. When boxes are installed above an acoustic ceiling, it is generally acceptable to access them by removing ceiling tiles. However, the tiles must be easily removable and replaceable without causing damage to the ceiling or creating a safety hazard. It is also essential to ensure that the boxes are not obstructed by ductwork, piping, or other building systems that could impede access. Proper labeling is also crucial. All junction boxes should be clearly labeled to indicate their purpose and the circuits they serve. This helps to prevent confusion and ensures that maintenance personnel can quickly identify the correct box when troubleshooting or performing repairs. The label should be durable and resistant to fading or damage from environmental conditions. When working with electrical systems, safety is paramount. Always to energize the circuits before working on any electrical components. Use appropriate personal protective equipment, such as safety glasses and gloves, to protect yourself from potential hazards. If you are not comfortable working with electricity, it is best to consult with a qualified electrician. In summary, supporting 1900 boxes above an acoustic ceiling requires careful consideration of the NEC requirements. The boxes must be independently supported by hanger wires or a properly supported raceway system. The support system must be securely attached to the building structure and capable of handling the weight of the box and its contents. Accessibility and labeling are also essential factors to ensure safe and efficient maintenance and repairs. By following these guidelines, you can ensure that your electrical installations are safe, compliant, and reliable. Let's delve into some more details about the specific requirements and best practices for supporting electrical boxes above acoustic ceilings. To reiterate, the NEC is the primary reference for electrical installations in the United States, and it provides detailed guidelines for ensuring safety and compliance. Section 314 covers outlet boxes, device boxes, pull boxes, junction boxes, conduit bodies, and fittings. As previously mentioned, 314.27c and 314.23 are particularly relevant to this topic. 314.27c emphasizes that electrical junction boxes must be securely fastened in place. This means that the support system must be robust enough to withstand the weight of the box, the wiring within, and any connected fixtures or equipment without sagging, shifting, or detaching. The support system should also be resistant to vibration and other mechanical stresses that could compromise its integrity. 314.23 further clarifies the requirements for supporting surface raceways, which can be used to support electrical boxes. It specifies that surface raceways must be supported at least every 6 feet and within 12 inches of each outlet box, device box, junction box, and termination. This ensures that the raceway is adequately supported to prevent it from sagging or pulling away from the boxes. When using hanger wires to support electrical boxes, it is crucial to select the appropriate gauge and type of wire. The wire gauge should be sufficient to handle the weight of the box and its contents with a safety factor. The wire should also be suitable for the environmental conditions in which it will be installed. For example, if the area above the ceiling is damp or corrosive, a corrosion-resistant wire should be used. The hanger wires should be securely attached to the building structure using appropriate fasteners. This could include screw anchors, toggle bolts, or other types of fasteners that are designed to provide a strong and reliable connection. The fastener should be installed in accordance with the manufacturer's instructions. The hanger wires should be attached to the electrical box using specialized clips, brackets, or straps. These devices are designed to distribute the weight of the box evenly and prevent the wires from damaging the box or its contents. The clips, brackets, or straps should be made of durable materials that are resistant to corrosion and other environmental factors. When using a raceway system to support electrical boxes, it is essential to select the appropriate type and size of raceway. The raceway should be sized to accommodate the number and size of conductors that will be installed within it. The raceway should also be suitable for the environmental conditions in which it will be installed. For example, if the area above the ceiling is damp or corrosive, a liquid-tight raceway should be used. The raceway should be supported in accordance with NEC requirements, typically every 6 feet and within 12 inches of each box or termination point. The support should be securely attached to the building structure using appropriate fasteners. In addition to the structural support, accessibility is a critical consideration when installing electrical boxes above acoustic ceilings. The NEC requires that junction boxes be accessible after installation, which means that they must be located in a manner that allows for inspection, maintenance, and repairs without requiring significant disassembly of the building structure or finishes. When boxes are installed above an acoustic ceiling, it is generally acceptable to access them by removing ceiling tiles. However, the tiles must be easily removable and replaceable without causing damage to the ceiling or creating a safety hazard. It is also essential to ensure that the boxes are not obstructed by ductwork, piping, or other building systems that could impede access. Proper labeling is also crucial for ensuring safe and efficient maintenance and repairs. All junction boxes should be clearly labeled to indicate their purpose and the circuits they serve. This helps to prevent confusion and ensures that maintenance personnel can quickly identify the correct box when troubleshooting or performing repairs. The labels should be durable and resistant to fading or damage from environmental conditions. When working with electrical systems, safety is paramount. Always to energize the circuits before working on any electrical components. Use appropriate personal protective equipment, such as safety glasses and gloves, to protect yourself from potential hazards. If you are not comfortable working with electricity, it is best to consult with a qualified electrician. Furthermore, consider the specific requirements of your local jurisdiction. Some jurisdictions may have additional requirements or interpretations of the NEC that you need to be aware of. It is always a good idea to check with your local building department or electrical inspector to ensure that your installations are in compliance with all applicable codes and regulations. Let's consider some practical examples of how to support electrical boxes above acoustic ceilings in different situations. Firstly, in a commercial building with a concrete slab above the acoustic ceiling, hanger wires can be attached to the concrete slab using screw anchors or expansion bolts. The hanger wires can then be connected to the electrical box using specialized clips or brackets. Secondly, in a commercial building with structural steel framing above the acoustic ceiling, hanger wires can be attached to the steel beams using beam clamps or other types of fasteners designed for this purpose. The hanger wires can then be connected to the electrical box using specialized clips or brackets. Thirdly, in a residential building with wood framing above the acoustic ceiling, hanger wires can be attached to the wood joists using screws or nails. The hanger wires can then be connected to the electrical box using specialized clips or brackets. Fourthly, in situations where it is not possible to attach hanger wires directly to the building structure, a trapeze support system can be used. A trapeze support system consists of two vertical supports that are attached to the building structure and a horizontal support that spans between the vertical supports. The electrical box can then be attached to the horizontal support. Finally, in situations where it is necessary to run wiring above the acoustic ceiling for a long distance, a raceway system can be used. The raceway system can be supported by hanger wires or trapeze supports. The electrical boxes can then be attached to the raceway system. Remember, the key is to ensure that the electrical boxes are securely supported independently of the acoustic ceiling grid and that they are accessible for maintenance and repairs. By following the NEC requirements and best practices, you can ensure that your electrical installations are safe, compliant, and reliable. To add further clarity, consider these points regarding the materials and methods used for supporting electrical boxes above acoustic ceilings. Firstly, the choice of materials for hanger wires, clips, brackets, and raceways should be appropriate for the environment. Galvanized steel or stainless steel is often preferred in damp or corrosive environments to prevent rust and degradation. Secondly, the size and spacing of hanger wires should be determined based on the weight and dimensions of the electrical box and its contents. A general rule of thumb is to use at least 2 hanger wires per box and to space them evenly to distribute the weight. Thirdly, when attaching hanger wires to the building structure, ensure that the fasteners are properly sized and installed according to the manufacturer's instructions. The fasteners should be capable of withstanding the anticipated loads without pulling out or loosening. Fourthly, when using a raceway system, ensure that the raceway is properly supported and that the connections between raceway sections are tight and secure. This will help to prevent the raceway from sagging or separating over time. Fifthly, when installing electrical boxes above acoustic ceilings, it is important to consider the potential for condensation. Condensation can form on the surface of the boxes and wiring, which can lead to corrosion and electrical problems. To prevent condensation, consider using insulated electrical boxes or installing a vapor barrier above the ceiling. Sixthly, when working with electrical systems, always follow safe work practices. Energize the circuits before working on any electrical components, and use appropriate personal protective equipment such as safety glasses and gloves. If you are not comfortable working with electricity, it is best to consult with a qualified electrician. Seventhly, remember that the NEC is a minimum standard, and it may be necessary to exceed the NEC requirements in certain situations. For example, if the area above the ceiling is subject to excessive vibration or other mechanical stresses, it may be necessary to use heavier gauge hanger wires or more frequent supports. Eighthly, keep accurate records of all electrical installations, including the location of electrical boxes, the type and size of wiring, and the methods used for supporting the boxes. This information will be valuable for future maintenance and repairs. Ninthly, regularly inspect electrical installations to identify any potential problems, such as sagging hanger wires, loose connections, or damaged wiring. Address any problems promptly to prevent them from escalating into more serious issues. Finally, stay up to date on the latest NEC requirements and best practices. The NEC is updated every 3 years, and it is important to be aware of any changes that may affect your electrical installations. By following these guidelines, you can ensure that your electrical installations above acoustic ceilings are safe, compliant, and reliable for years to come. Now, let's address some common misconceptions about supporting electrical boxes above acoustic ceilings. Firstly, one common misconception is that it is acceptable to support electrical boxes solely from the acoustic ceiling grid. As mentioned earlier, this is generally not acceptable because the ceiling grid is not designed to bear the weight of electrical components. Supporting boxes from the ceiling grid can lead to sagging, damage, and even collapse of the ceiling. Secondly, another misconception is that it is acceptable to use small gauge wire for hanger wires. Small gauge wire may not be strong enough to support the weight of the electrical box and its contents, especially over time. It is important to use hanger wires that are of sufficient gauge and strength to handle the anticipated loads. Thirdly, a third misconception is that it is not necessary to label electrical boxes that are located above acoustic ceilings. Proper labeling is essential for ensuring safe and efficient maintenance and repairs. Without proper labeling, it can be difficult to identify the purpose and circuits served by the boxes, which can lead to confusion and potential hazards. Fourthly, a fourth misconception is that it is not necessary to inspect electrical installations above acoustic ceilings regularly. Regular inspections are important for identifying any potential problems such as sagging hanger wires, loose connections, or damaged wiring. Addressing these problems promptly can prevent them from escalating into more serious issues. Fifthly, a fifth misconception is that it is acceptable to ignore the NEC requirements when installing electrical boxes above acoustic ceilings. The NEC is a minimum standard for electrical safety, and it is important to comply with all applicable codes and regulations. Ignoring the NEC requirements can lead to unsafe installations and potential liability. Sixthly, it is not acceptable to assume that the weight of the box and its contents is negligible. Even seemingly light components can add up, especially when considering the cumulative weight of multiple boxes and long runs of wiring. Always calculate the anticipated load and select support materials accordingly. Seventhly, it is not acceptable to compromise on the quality of materials used for support. Cheap or substandard materials may fail prematurely, leading to safety hazards and costly repairs. Invest in high-quality materials that are designed to withstand the rigors of the environment. Eighthly, it is not acceptable to cut corners on installation techniques. Proper installation is just as important as the quality of materials. Follow the manufacturer's instructions carefully and ensure that all connections are tight and secure. Ninthly, it is not acceptable to neglect the potential for future modifications or additions. Consider the possibility that additional wiring or equipment may need to be added to the boxes in the future. Ensure that the support system is capable of handling the additional load. Finally, it is not acceptable to disregard the importance of proper documentation. Maintain accurate records of all electrical installations, including the location of boxes, the type and size of wiring, and the methods used for supporting the boxes. This information will be invaluable for future maintenance, repairs, and modifications. By avoiding these common misconceptions and following the NEC requirements and best practices, you can ensure that your electrical installations above acoustic ceilings are safe, compliant, and reliable for the long term. Let's now address the specific question of whether it is permissible to support 1900 boxes with EMT supported by hanger wires above an acoustic ceiling used as junction boxes for lighting whips, or whether the boxes have to be separately supported. The answer, based on the NEC, is that the 1900 boxes must be independently supported. While EMT conduit can be supported by hanger wires, this support does not automatically extend to the boxes attached to the conduit. The NEC requires that each box be independently supported to ensure its stability and prevent stress on the conduit system. Therefore, you cannot rely solely on the EMT support to also support the 1900 boxes. Each box must have its own dedicated support system, whether it be hanger wires directly attached to the box or another approved method as outlined in the NEC. In practical terms, this means that you would need to install separate hanger wires or other support specifically for the 1900 boxes, in addition to the supports for the EMT conduit. The supports for the boxes should be attached to a structural element of the building, such as the concrete slab or steel framing, and should be capable of handling the weight of the box and its contents. To summarize, while EMT conduit can be supported by hanger wires above an acoustic ceiling, this does not satisfy the NEC requirement for independent support of the 1900 boxes attached to the conduit. Each box must have its own dedicated support system to ensure its stability and prevent stress on the conduit system. Adhering to this requirement is crucial for ensuring electrical safety and compliance with the NEC. Let's delve deeper into the practical considerations of implementing these requirements. Firstly, when installing hanger wires for both the EMT conduit and the 1900 boxes, it is important to coordinate the placement of the supports to avoid interference. The hanger wires for the boxes should be positioned in a way that does not obstruct the conduit or its supports, and vice versa. Secondly, when attaching hanger wires to the boxes, use appropriate hardware, such as conduit clamps or box hangers, to ensure a secure and reliable connection. Avoid using makeshift or unapproved methods, as these may not provide adequate support. Thirdly, when running EMT conduit above an acoustic ceiling, it is important to maintain proper clearances from other building systems, such as ductwork and piping. The conduit should be installed in a way that does not obstruct access to these systems or create a safety hazard. Fourthly, when making connections inside the 1900 boxes, ensure that the wiring is properly sized and insulated, and that all connections are tight and secure. Use appropriate wire connectors and follow the manufacturer's instructions carefully. Fifthly, when installing lighting whips from the 1900 boxes to the light fixtures, use flexible metal conduit or other approved wiring methods to provide mechanical protection for the wiring. The lighting whip should be securely attached to both the boxes and the fixtures. Sixthly, before energizing the circuits, thoroughly inspect all wiring and connections to ensure that they are properly installed and that there are no potential hazards. Use a multimeter or other testing equipment to verify that the circuits are properly wired and that there are no short circuits or ground faults. Seventhly, after energizing the circuits, monitor the lighting system for any signs of problems, such as flickering lights, overheating, or unusual noises. Address any problems promptly to prevent them from escalating into more serious issues. Eighthly, keep accurate records of all electrical installations, including the location of the 1900 boxes, the type and size of wiring, and the methods used for supporting the boxes and conduit. This information will be valuable for future maintenance and repairs. Ninthly, regularly inspect the electrical installations above the acoustic ceiling to identify any potential problems, such as sagging hanger wires, loose connections, or damaged wiring. Address any problems promptly to prevent them from escalating into more serious issues. Finally, stay up to date on the latest NEC requirements and best practices for installing and maintaining electrical systems. The NEC is updated every 3 years, and it is important to be aware of any changes that may affect your electrical installations. By following these practical considerations and adhering to the NEC requirements, you can ensure that your electrical installations above acoustic ceilings are safe, compliant, and reliable for the long term. To provide further clarification, let's address some potential scenarios that may arise during the installation process. Firstly, if you encounter obstructions that prevent you from installing hanger wires in the desired locations, you may need to relocate the boxes or the conduit. Alternatively, you may be able to use a different type of support system, such as a trapeze support or a strut system. Secondly, if the acoustic ceiling is particularly fragile or susceptible to damage, you may need to take extra precautions to protect the ceiling during the installation process. This may involve using specialized tools or techniques to minimize the risk of damage. Thirdly, if the area above the acoustic ceiling is difficult to access, you may need to use specialized equipment, such as a scissor lift or a boom lift, to reach the work area safely and efficiently. Fourthly, if you are working in an existing building, you may encounter existing wiring or other building systems that you need to work around. Take extra care to avoid damaging these systems, and consult with a qualified electrician if you are unsure how to proceed. Fifthly, if you are working in a dusty or dirty environment, you may need to take extra precautions to protect yourself from dust and debris. This may involve wearing a dust mask or other respiratory protection, and cleaning the work area regularly. Sixthly, if you are working in a hot or humid environment, you may need to take extra precautions to prevent heat exhaustion or dehydration. This may involve taking frequent breaks, drinking plenty of water, and wearing lightweight clothing. Seventhly, if you are working at night or in a poorly lit environment, you may need to use supplemental lighting to ensure that you can see the work area clearly and safely. Eighthly, if you are working alone, you may need to take extra precautions to ensure your safety. This may involve letting someone know where you are working and when you expect to be finished, and carrying a cell phone or other communication device. Ninthly, if you are unsure about any aspect of the installation process, consult with a qualified electrician or other expert. It is always better to err on the side of caution than to take risks that could jeopardize your safety or the integrity of the electrical installation. Finally, remember that the goal is to create a safe and reliable electrical system that will provide years of trouble-free service. By following the NEC requirements, best practices, and these practical considerations, you can achieve this goal and ensure the safety of yourself and others.